Okay, so question 3.
Yep.
Okay. Find the margin of error for a 90% confidence interval when the standard deviation is sigma 50 and sample size 25. Confidence interval. Eesh, I didn't study that yet. But I think what they're talking. So do we just divide? No. Let me think.
So I think I've got it. So the formula is, for margin of error, it is going to be the Z value per confidence interval, which what you do is you go to the probability applet, you highlight the middle section, and then you type in 0.95 in this case. Since it was 95%, right? Or 90%, sorry.
Yeah.
So let me go ahead and try that again. But you put in 0.90 on the applet. Are you doing that right now? I'll just kind of walk
for
you
the
through
Z-score, right?
Yeah, to get the Z-score.
Yeah.
So you get the Z-score, which is 1.645.
Mm-hmm.
Okay,
yep.
All right, and then I forget.
Oh. Okay, sorry, go ahead.
Oh, so yeah, the formula is that you have, the Z-score and times, is it sigma over the square root of the sample size?
Yes.
Yeah. So I got 16.45. Let me know when you have that.
Okay, I got 10. That's totally not right. So let me try this again. Okay, 50 divided by square root of 25. Yeah, I got 10 again. That's weird.
Well,
that can't be right.
You got 10, but then it's the Z-score times 10. So 16.45.
Oh, right. Okay.
Does that make sense?
Yeah, for sure. 16.45. Gotcha. Okay, cool.
I mean, that makes sense to me. So I guess we'll see when we submit it if we're doing that right. But I put all of the formulas into an Excel spreadsheet, and so I've got them all right here, and hopefully we can crank them out pretty fast. Idea. Hold on just a second.
Sure.
Okay. Cool. So on to question 4. Which of the following statements is true?
Okay. Okay. I'm going to go back and look at the textbook real quick. Oftentimes, I think if I go, okay, so we go down to summary. Well, hey, I'm looking at the summary, and I know for a fact you did that formula correctly.
Awesome.
For problem 3.
Cool.
So it says down here, I'm looking at the summary too, in the box here, and it says that a confidence interval is an interval estimator used to give a range of plausible values. Is that what they're asking for, the interval estimator?
Yeah, it's just which of the following statements is true, but most of them have to do with either interval estimator or point estimator.
Okay. Okay, that's not going to be helpful right there. Okay, so the point estimate is the first thing that appears. So it's the what do you call that? The X with the hat thing.
Oh, sample mean?
Distribution of sample means.
Yeah.
Okay. Going back. So it's the point estimator of. So I think it's number 2.
Okay, so the sample mean is the point estimator of the U thing. I can't remember what it's called.
Yeah, the population parameter thing, the population mean. That's what it is, population mean.
Population mean? Okay. Awesome. Yeah, let's go with that one then.
All right.
Do you know what 5 would be, what it's looking for with that?
Girl, say Gina wants to construct an 95% confidence interval for GMAT scores. She knows standard deviation. Boom. Boom. Computes X equals. Okay. So what is the point estimate for the true GMAT score? Oh, I think it would be the 526 because that's
yep.
the X thing again.
Yeah, you're right.
Hope so.
Well, I just went back and looked at I have my video paused on his big example that he did in the video.
Sweet.
And that's actually
Okay.
the first question. What's the point estimate of the true mean GPA? And he's just
sweet.
taking, what the sample mean was.
Okay.
So yeah, you're right, 526. Okay, the margin of error for 95% confidence interval. So I've already put all this into my Excel spreadsheet. So I have 1.96 for the z-score, which I use the applet for. For sigma, 113. Then the square root of 64 is 8, and then 526. And so my margin of error was 27.685.
Did you just go and so when you set up these formulas in Excel, did you just do that all on your own, or did you follow, is there like a guideline video to sort of set it up?
No, I just did it all on my own.
Okay, that's a really good idea. I'm gonna do that too.
Yeah, it's helped a lot. And so
yeah,
I just watch the video and then I watch, his most detailed example, and then I find a way to build it in Excel to where it brings up the same answer that he gets.
correct, and then you can use it for anything else.
Yeah.
Cool.
And so, I should have the next 3 answers just sitting here on my spreadsheet right now.
Freak, yeah. So for 6 then, I'm sorry, what was that? What was the answer?
So 27.685. I'm just looking to see, are we assuming that we round to 3 decimal places still?
I believe so.
It doesn't say anything for 6. On 5, or on 7 and 8, it asks for it, but.
Okay. It says at the top, when calculating anything, remember to round to 3 decimal places unless otherwise specified.
Cool. Well, 27.685. And then 7, I have 498.315.
Point what? Sorry, what was the point?
0.315.
Okay.
And then for 8, I have 553.685. So I think 9 is it would decrease. Because if you have a greater sample size, then there's less variance.
Yeah, that's true.
Okay, 10. What would happen to the width of the confidence interval if Gina changed to a 99% confidence interval? It would increase, right? That way she's more confident that it falls in those parameters, and so the interval.
Oh yeah. That's right. So
increase.
So then it would increase. Give her a little more leeway.
Right. Yep.
Be less specific. Okay. Yeah, that makes sense.
Awesome. Okay, we're almost done. Okay, question
Yeah, dude.
11.
Okay, I'll read it.
Yeah, go for it.
Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Okay. So we just gotta find out like what value we need for in the.
Yeah, so I might be able to get this really fast.
Oh, sweet! You can also put that in Excel.
Yeah,
Nice.
I built one of those too. Let me just double check with the video
Dude,
and make sure that
I'll
I'm
do that.
pulling the right things. Okay, so I think I have an answer, but let me double check real fast.
Okay.
Yeah, so I think I've got it.
Sweet.
So I have, let's see, hold on. So round up to the nearest whole number. So 246. And I got that by taking the z-score times it by the standard deviation, and then dividing it by the margin of error, and then squaring that.
Okay. Man, I'm gonna go back and I'm gonna create that an Excel spreadsheet too, and just get all the formulas, everything we covered. So.
Yeah, let me show you. I think there's a way to share my screen, and I'll show you. So do you see that?
Oh yeah.
It's really simple. So here are my answers, and so this is the answer that we just got. This is the portion of the spreadsheet that we've been using up to this point, and then these are the answers for the high and low. So yeah, I mean, it's just super simple, but it so far has been able to bring up all of our answers.
That's awesome. So you got the so like the z-score, you got sigma and stuff. Are those like the inputs?
Yeah. So these are the inputs right here.
And then you like divide or multiply or.
Right, and then so like right here, I just have my formula. These inputs. Same goes for here. Yeah, so I mean, it's not very pretty, but I made it in like 5 minutes, and it has saved us a lot more time than that.
Yeah. Sure. Okay. Yeah, I'm gonna do that Wednesday. So you're not just doing all the work by yourself.
Okay, yeah, that'd be good to have a couple of us with spreadsheets that we're using.
Yeah, for sure. Okay. Awesome. And then we got on question or 12. 12.
Yeah, so for 12,
let's see. They got a mean salary of 100,000. The standard deviation is 36,730. You are interested to know if the mean salary for women is different than from the population mean. but I'm not sure if it is higher or lower. You set up a hypothesis test with a level of significance 0.05. Okay, you collect a sample random sample of 36 women's salaries and find that, so basically their mean of the samples, 11,000. So what is the lower limit of this 95% confidence interval? Okay, what is the lower limit? Is that like the other, or?
So it's like if
just punching all these values into
if Donald Trump is polling nationally at 48%, with a confidence interval of or with a margin of error of 3, or something like that, it's the lower. It's it's plus or minus 3, and so the lower limit would be 45. Upper limit would be 51. Does that make sense?
Gotcha. Yeah. Mm-hmm. Okay. Yeah, that makes sense. Okay.
So I think I've got it, but I don't. I think the majority of that information we don't need because it's not part of the formula. But
okay.
I could be wrong. But my answer is for the lower limit. I have 99,002.
Okay.
Okay, the upper limit, I have, let's see here. I have 122,998.
Alrighty. Cool.
And then 14, there are 3 requirements that need to be checked when computing a confidence interval for a mean. They are...
I'm assuming the top one is... Oh, you think it's all of the above?
I think it's probably all of the above.
Yeah, because for one thing, you can't... They're asking for 3, and you can only select one anyways.
Right.
Like, kind of a...
Yeah, it's a pretty easy question.
All right, do you want me to go ahead and submit?
So I just submitted it, and...
Okay.
Boom. Looks like we have everything.
No way. Awesome.
Okay, yeah, that's all right.
Awesome. Hey, well, good work. Okay, I'm going to get that spreadsheet thing fixed or actually make one, catch up in the lessons so I'm not just, riding your coattails the whole time.
Sounds good. Yeah, the spreadsheet for this stuff helps a ton. And I made one because he said that we could use Excel on the exam, and so when I was taking the exam, I just opened up Excel and I knew the formulas, and I just created that while I was in the exam.
Dang it, that was a really good idea. Okay.
So I mean, I think that was fine. I mean, it said that we could use Excel, and he even provided some spreadsheets that helped. But I just made my own.
Okay.
So.
Awesome deal.
Cool. Yeah. Well, thanks, Daniel.
Okay, Brady. Well, you have a great rest of the day.
You too. We'll see you.
Hey, thanks, man.
Yep.